So this question, we have two functions. F of x is 2 over x minus 3, and g of x is 5 over x plus 4. We want to evaluate f circle g of x and find its domain. So, challenging question. F circle g of x means f of g of x, which means f of 5 over x plus 4. So I have to look at this first, and I've got to recognize that division by 0 is a problem. I cannot divide by 0. So when is the bottom of this thing 0? The bottom of this thing is 0 when x plus 4 is 0. So if x equals negative 4, we have a problem. So x equals negative 4 is not in the domain of f circle g. Because you're going to see in a minute we're going to do something different, because what does f do? F of x is 2 over x minus 3, so f of something is 2 over something minus 3. So f of something is 2 over something minus 3. Now what is the something here? The something here is 5 over x plus 4. So this is f circle g of x. Of course, we should simplify it, but we have actually expressed it in a form. We just need to get it in a simpler form. But don't forget, negative 4 is not acceptable. Negative 4 is not in the domain of f circle g. So let's do some simplification. F circle g of x is 2 over 5 over x plus 4 minus 3. I'd like to simplify the bottom. 5 over x plus 4 minus 3 over 1. Common denominator, x plus 4 times 1. So 5, what's new on the bottom, multiplied by 1. Negative 3, what's multiplied on the bottom? X plus 4. So we get 5 over x plus 4, negative 3x minus 12 over x plus 4. And I've got to put these together. So it's this plus 5 over x plus 4 plus negative 3 over 1 is how I want to perceive it. So I have 5 over x plus 4 plus negative 3x minus 12 over x plus 4, which I can get as a single fraction, 5 plus negative 3x minus 12 over x plus 4, which gives me negative 3x, 5 minus 12 is minus 7 over x plus 4. So that's the bottom. Remember, this is the denominator of this big fraction up here. So this is the bottom. This is 5 over x plus 4 plus negative 3 over 1. So currently my f circle g of x is, the top is 2, which I'm going to call 2 over 1. The bottom is what I just simplified, is negative 3x minus 7 over x plus 4. So if that's the case, what are we going to do? This means 2 over 1 divided by negative 3x minus 7 over x plus 4. So invert and multiply, we get 2 over 1 times x plus 4 over negative 3x minus 7. So 2 times x plus 4, 2x plus 8 over negative 3x minus 7. This is what f circle g of x is, sort of. But remember, we have to figure out the domain. And we already said on the first page that x equals negative 4, not in the domain. Now here, negative 3x minus 7 also cannot be 0. So let's find a part of the page to do that analysis. What if negative 3x minus 7 is 0? That means negative 3x equals 7 divided by negative 3. That means x is negative 7/3. So negative 7/3 is not in the domain. So let's try to collect all this information that we have, and then we'll try to check it as best we can. We believe that f circle g of x, with some tricky algebra, is 2x plus 8 over negative 3x minus 7. And we said the domain does not include, throw out negative 4, throw out negative 7/3. So if I lay out my number line here, negative 4 is negative 12/3, so that comes first. Negative 4 is removed. Negative 7/3 is removed. So if I want to express my domain, looks like that. So in interval notation, negative infinity to negative 4 round bracket union, negative 4 to negative 7/3. Excuse me, negative 4 comma, negative 7/3 union, negative 7/3 to infinity. So negative 4 comma, negative 7/3. Sorry about that. I got a little carried away. That is your domain. Now, I'd very much like to check that. So let's go back to our original page here. We have f is 2 over x minus 3, and g is 5 over x plus 4. I want to put those in the graphing calculator. Watch your order of operations. So f is 2 over x minus 3, 2 divided by parentheses, x minus 3. And g is 5 over parentheses x plus 4. And I was interested in f circle g, that would be y1 of y2 of x. How do I see that? Vars, y vars, function y1 of vars, y vars, function y1 of y2 of x. And I'm going to turn off the first two because I'm really only interested in the third function, which is black. Let's try zoom decimal, see what that looks like. So this is what we believe f circle g of x is. So great, we have a few points on here to work with. And what did I compute it to be? I computed it to be 2x plus 8 over negative 3x minus 7. So let's see if that's the case. 2x plus 8, negative 3x minus 7. So that's going to come in pink, I believe. And we'll see if the graphs are identical. 2x plus 8 divided by negative 3x minus 7. Whoops, let's try that again. 2x up here, 2x plus 8 divided by parentheses negative 3x. Negative is down here, be careful with that. Negative 3, again, x is up here. Minus 7, minus is over there. So we would like the black and the pink functions to be the same. The black function is already there. Notice the pink is drawing right on top of it, so that makes me feel pretty good. But now I want to think about the domain of f circle g, right? F circle g is which function? F circle g is y3, so I'm going to turn off y4. I'm just going to look at y3. I'm going to go to the table and I'm going to try to figure out something about the domain. Let's go to automatic first, and then we'll put in our own numbers. So second table, here's some numbers. Then I'll change that to ask. Second table set ask. And we'll plug in some numbers. Second table. Nope, I wanted to ask. Second table set. Wanted to ask. I guess I didn't save that. Enter, enter. Now we'll go to second table. So does 4 work? Does 5 work? Does 7 work? 4 gives me an answer. 7 gives me an answer. 0.1 gives me an answer. But what did I say I had to throw out? Remember, what did we have to remove? What did we say? We said -4 is not in the domain. We said -7/3 is not in the domain. How does the calculator see that? -4, is that in the domain? Error, no. How about -7/3? Is that in the domain? No. So that's a way to kind of check your work to see if what you have is reasonable. So there is one other question of that type where instead of doing F circle G, we're going to do G circle F. And remember, G circle F and F circle G aren't typically the same. And then we'll identify how that's going to affect our domain and such. So what do we have here? We want to get G circle F, and we want to find the domain of G circle F. So G circle F of X is G of F of X, which is G of F, which is 2 over X minus 3. And you see right away, 3 cannot be in the domain. You make that note. Now, what does G do? G is 2 over X minus 3. So G of something is 2 over something minus 3. What is the, nope, check that. That's not G, that's F. So let me fix that with a different piece of paper. One more time. What does G do? G does 5 over X plus 4. So I think I can probably move that out and move this up. All right, so except I need to see what F and G are. Okay, there we go. Now we've got it. So G is 5 over something plus 4. So G of this is 5 over the something plus 4. What is the something here? 2 over X minus 3. So just like on the last problem, I've got to add these fractions on the bottom. 2 over X minus 3 plus 4 over 1. Common denominator, X minus 3 times 1. Of course, the 1 is not really necessary. 2 times 1 here, 4 times X minus 3 there. So we get 2 over X minus 3 here, 4X minus 12 there. Over X minus 3. We're going to add these guys together. So 2 over X minus 3 plus 4X minus 12 over X minus 3. And what is that going to give me? 2 plus 4X minus 12. How about How about 4x minus 10 over x minus 3? But remember, that's just the bottom. That's all I've done. That's all I've done is I've simplified the bottom. So this is the bottom. This is the denominator. So the top is 5 over 1. The denominator at the bottom is 4x minus 10 over x minus 3. What does that mean? That means 5 over 1 divided by 4x minus 10 over x minus 3. which is 5 over 1 times x minus 3 over 4x minus 10, which gives me 5 times x minus 3 over 1 times 4x minus 10, which is 4x minus 10, 5x minus 15 over 4x minus 10. Earlier we said 3 is not in the domain. Remember that made this thing into a 0. 3 is not in the domain. Also, 4x minus 10 can't be 0. So let's take a quick look at that. When is 4x minus 10 0? When 4x is 10, when x is 10/4, which is 5/2. So 5/2 is not in the domain. So remember, this was G circle F. So we have our G circle F of x, which is here. 3 is thrown out 5/2, which is 6/2, awfully close to 3, also not in the domain. So let's go ahead and collect all that information. So we believe, given all this information, we believe that G circle F of x is 5x minus 15 over 4x minus 10. You could factor these. I don't think that's any simpler. We have to remove 3. 5/2 not in the domain. So knowing that, there's 5/2 is before 6/2. There's 5/2. There's 3, very close to each other. So my domain would include these 3 intervals. This one, and this one. So negative infinity to 5/2. Union 5/2 to 3. Union 3 to infinity. And as always, let's check it on the graphing calculator and see if that's supported. Remember, we called G y2. So I want to see what y2 circle y1 is, or y2 of y1 of x. Hopefully it's 5x minus 15 over 4x minus 20. So let's do that. We have y1 and y2 there, so we will erase these other guys. I don't need these anymore. This time I want G circle F, so that'll be y2 of y1. So vars, y vars, function, y2 of y1 of x, parentheses, vars, y vars, function, y1 of x. I'll do a zoom decimal again, see if that's decent. If not, I'll change it. So what I'm doing in black is supposed to be y2 circle y1 or y2 of y1 of x. So we see quite a bit there. And what is it supposed to be? What is it supposed to be? We hope that it is 5x minus 15 over 4x minus 10. So I will put that in to see if the graphs match. Five x minus 15 over 4x minus 10. 5x minus 15 divided by 4x minus 10. And let's see if those functions are the same. The black one is what we had before. The black one was G circle F. And notice they match up, which makes me feel very good about myself. And the last thing I want to do is I want to check on the domain. So I'm going to turn off Y4. I'm going to go back, so you click on the equal sign and hit enter. I'm going to just look at Y3, and I'm going to see if 3 or 5/2 are allowed. Second table, I'm still in ask mode. So notice those numbers are all okay. But I think 3 is a problem. If I type in 3, what do I get? Error. If I type in 5/2, what do I get? Error. Neither of those are on the graph, so those are not in the domain. So that makes me feel pretty good about what we had before. So indeed, that's our G-circle f of x. Domain throws out 3 and 5/2. That's how we express our domain in interval notation.